Hello everyone and welcome to Handmade Heroes, show where we code a complete game live on stream. We have some debugging to do today. What we'd like to do is put a bunch of art in the game because we have the opportunity to do that now. And we just have to finish up our art pipeline stuff that is, I think, mostly written, but it's not necessarily working. We have to go through and debug a bunch of stuff, and there's a couple ways we can do that. One of the things that I'd like to do today is actually do a little bit of adding code to debug. It's not new code that we actually are going to use in the game, but I'd like to make a little more debug infrastructure that we can use. And so let me talk a little bit about what I mean by that. So right now what we're doing, and if I remember correctly from last week, what we were doing was just saying, look, we would like to do tagging and finding of assets, but what we saw is, well, actually it kind of worked, but it kind of didn't, because you can see we definitely loaded some stuff in, but there's a couple things we can see. First of all, we're upside down, which we do kind of expect because PNGs are backwards from how our textures are. They go, when you start to decode a PNG, the first row of pixels that you get in a PNG, because remember we wrote the PNG reader on stream, so we're going full bore here. The first row of pixels in a PNG is actually the top, like physical top of the thing. So, you know, if you were to look at something like a human, the head would be on that first row of pixels, right? Would be where that starts. The feet would be down where the last row of pixels is, right? But that's not how textures work in 3D hardware. In 3D hardware, when you think about what's at the zero, so the first row that you would submit, that's actually the bottom physically of the texture. So it's difficult to talk really about those things constructively, because what the other thing you have to remember in 3D is, since it's a world and you're just talking about mapping images into the world, top and bottom is really more conventional than anything else. But we chose the convention that we will stick with the standard math axes, which is that y goes upward, not downward, right? If we had chosen to go with a convention where y goes downward, then we would agree with PNG in the sense that PNG has 0 and then increasing values of y, increasing row indices go down, right? So you have to understand all of these things in your head. I know it's difficult, but this is where these sorts of problems come from, and obviously we have this situation where we have to make all of these things line up. So what I mean by the upside down thing being expected is this is something I knew we would deal with. It's not a shock to me that the things came in upside down, because that's just something we have to deal with. So we have to decide how exactly we want to handle that and so on. That's not particularly concerning. What does concern me is the blue tone. I do not understand where that's coming from. That's a weird one. So we have some debugging to do there. And then I think we've got one other thing to worry about here, which is that we also have a bug with our picking. So the way we're setting up the tags, or picking with the tags, is wrong. So we have a couple bugs that we want to look into, and I don't know that they're going to be complicated, but what I do know is this is the sort of thing that could get complicated quickly. Why? Because we have many steps in the process. The artist makes a PNG, the PNG like exported from Photoshop, right? So really they make a Photoshop thing, then they export a PNG from that. That PNG is loaded into our game by our decoder and loader, right? It is then packed into a uniform data format that has some meta information on it so that we can quickly load where it is and know what it is, so that we don't have to like iterate over everything every time we start the game and look at all the PNGs we have or anything like this, right? So we've got that. And then we've got the actual runtime code that looks through what's loaded to find matches for things that we ask for, right? And every one of those steps can have a bug. And there's even one more that we kind of know isn't a problem in some sense, but, you know, even really kind of could be, depending on, because of the lighting maybe, who knows, which is the actual rendering, you know what I mean? So when we actually go to render things, we could easily do something where we're screwing up the red or green channels there, or the blue channel there, or whatever, right? Or we're flipping things upside down inside the renderer when we shouldn't be, and things like this, right? So we have a large number of possible failure points. And so the reason I wanted to take the particular talk we're going to take today is not because I could now go debug those. We could probably debug them pretty cold, and it wouldn't be a huge deal. But I don't really want to spend a lot of time debugging these kind of issues all the time. So what I'd rather do is take one part of the puzzle away and just go, look, we've got this utility we wrote that's HHA edit, right? And in here you can do create, rewrite, info, dump, right? And so one of the things that we had was these two bottom ones that allow us to look at a particular one of our data, one of our HHA files, like the runtime data for the game. It allows us to look at one of those. So if we wanted to say, look, this is the imported art assets here, right? This is what we're running with. If I say HHA edit and I said info local.hha, it will tell me some information, right? Okay, so it's a version 1 file. It has 14 assets in it. There are 46 total tags, and it came with annotations in it, right? If I then say dump, right, what you can see here is we get all of the information about these things in here that is exactly what I want to know. So for example, I can see here that, like, okay, here's the Hand Dark Bones thing. It says this is the tile that it was imported from. It says that Anna's the person who made it. It says which file it was from, which is nice. We have a data pointer. It tells us 4 tags. And what you can see here is the piece of information I'm really interested in is sort of missing, right? I want to know what we tagged the thing, and unfortunately I can't see it, right? So it just says unknown. And so let's look at why that's true. That's the first thing I want to do today because I think it'd be easy for us to fix, and then we could look at that and eliminate that as a possibility. One thing. The other thing I'd like to do is I can't tell if this bitmap is correct, right? I have no idea what this bitmap looks like. So the other thing I could do is make in the like something like this, like dump BMP or something, and I could tell it take this local HHA and dump all the bitmaps out into a directory so I can look at them and see if they're all correct, so I can have a round trip there. So those two things aren't particularly hard to add to our HHA editor, so I think we should, because that way we can know like what's going on. The other thing we could do is make it so that the import path gets welded in here too, but I don't know how much we want to. I'm not going to do that because we don't really care, but something to think about maybe long term. So let's take a look at the first one. So we have some duplicated code, and the duplicated code is what's leading to this problem. So if we look, let me just load up the project here so we get all our files. So if we look inside Handmade asset, one thing we just kind of shoved in really quickly last week without really thinking about it was this right here. So this was a list of names that go with tags, you know what I'm saying? And if you take a look in our HHA editor, what you'll also notice is that it needs that as well. So if we go look at where it dumps the tags out, which is right here, print, oops, not what I wanted. Print contents. What you can see here is we have a print tag function, and that's what's being called to say for any given tag in the system what it is. And you'll notice we have a thing here called tag name from ID. Now, if I loft these two things together, you can see that essentially what we've got here is we've got two of the same things happening. This is a mapping of tag names where you can put in an ID and get out a tag name. This is the opposite. This is a thing where you can put in a name and get out a tag. And you can see why these two things are essentially the same, because they both maintain a mapping from IDs to names or back, depending on how you want to look at them. But the information that's contained in them is essentially the same. They're just optimized for a different direction of lookup. And what happens here is we end up in a situation where these two tables would always have to be synchronized, right? Anytime we add something, and this is exactly what happened, we made a table here that has a bunch of things for tags that we never went back and added. So when you print it out, you don't get the right results. So what would be nice, well, what would be really nice is if C or C++ actually had introspection in it, in which case neither of these two tables would even have to exist in the first place, but that's a separate issue. Since we don't have a language that actually is any good, what we can do is minimize the degree to which that language poops on us by saying, let's go ahead and make a unified place for this to occur, so we at least know if we could read the name in and set a tag, we can print the name, and so you're never going to have a situation where you really can import a tag you can't then export, right? It's always going to be the same. So what I want to do is unify these two together. And the way that I'm going to do that is I'm just going to go in and say inside the HHA file format stuff, which is this right here, we've got sort of the definitions of everything, right? Here's our basic categories and stuff like that, right? And we've got this asset tag ID here, and we know this is the master list because this is what's actually being used for compilation, and anything that's not in the master list here couldn't be referred to by code in any way, right? So we know this list is the correct list. So what I'd like to do now is say, well, maybe there's a handmade file formats.cpp. We have not had that previously, but we do have it now. So I'm going to go ahead and create one. Did I spell that wrong? Maybe I put it in the wrong directory. Hold on a second. Sorry, I don't know what I just did there. I wanted to make a new one in the code directory. Maybe I made it in the project directory. I don't know. Let's see. So, handmade file format. Made file formats.cpp. There we go. Sorry, I think I made it in the wrong directory there. So I didn't want to save it out to be in the wrong place. Anyway, so if we have a handmade file formats.cpp, what we can do is add some things in here that will be sort of universal ways to look this stuff up. And what we can do is go, all right, so inside the HHA editor, we kind of already have like one of those. So we've got this type from IDV0 table, right? So maybe that, you know, wants to be moved in there just because it's a name table, and let's just put those in here, right? So here's our type from ID table. And the other thing we can do is put those tag tables in there. So inside the asset system, right, we've got a name tag here. We can put those in as well. So we can go ahead and add this in there, like so. And we can also, inside the HHA edit, where we had those tags, we can put these in too, right? And so now what we want to do is figure out a way to kind of unify these two things together. So the first thing I want to do is to convert. I would like to use this kind of mapping, not this one. The reason for that is if you look at what might happen when we are doing stuff in this system, what you can see is that we have essentially a many-to-one kind of relationship going on with these names. There's only one set of IDs. So a tag underscore bones is always a tag underscore bones. There isn't some other tag like tag underscore bone without the S that also means the same thing. So inside our code, we are rigid about always having one identifier that means what it means, and there's never two identifiers that can mean the same thing. That's important for programming. That's what we do all the time. But in art land, it doesn't always happen. Sometimes people, because again, they don't have a compiler really, a lot of times to tell them that they used a term that's wrong. They're just naming something in Photoshop, and Photoshop can't check it for validity, right? So sometimes we would rather be more permissive in the exported thing rather than say, oh yeah, like when you go to import it, it gives you an error and go back to Photoshop and change the name of the thing, you know, stuff like that. So what we want to do is be more permissive there, which means we tend to have more than one textual name that can go with a particular tag, right? And so what we want to do is recognize that fact and set up a mapping that goes in that direction. So we can define lots of strings that map to a small number of IDs rather than lots of IDs that map to a small number of strings, because we're trying to model a specific one of those two things that's occurring. And so that's what we're doing here, right? And so what I'd like to do, and I'm going to move this down below it because it's not, this is some old stuff that probably won't come into play very often. What I'd like to do here is just say, okay, when we're compiling this stuff, what I'd like to do here is just say, let's stop using this tag name from ID, and we'll start using this. Now, I don't know if we actually want to have this this type from IDV0 actually in there. We might not. I don't know. We'll see. Because this can go away eventually, but you know, we'll see. This part here is here to stay, so this is the part that we want to focus on. And what I'd like to do is just go ahead and convert these things that we had already into sort of more the same format that we had below, right? So all of this stuff, while it's still in the tag system, we'll just go ahead and put in there. So if I look at what these things were, you know, in terms of tags, they kind of map directly over, right? So we know we've got, you know, smoothness, flatness, spacing direction, Unicode code point, you know, font type, shot index, layer index, primacy, and basic category. And so now we know that we've got a mapping between those two things. Done in exactly the same way that we were doing the other tags. So it's uniform, right? Don't really want that indented that way. Let's go ahead and get that out of here. There we go. So now we've got a table that's uniform. And now we just need to support the types of calls that we were supporting before, meaning we need to be able to use this table in some constructive way. So if I look at the HHA editor, what we needed is tag name from ID. So we want to turn that into, you know, a function, right? And that function needs to return exactly what it says. It needs to return a tag name in this case. And we use strings here, so in this case, I, again, probably want to... although we can actually have this return a char star as well. You can use either of those two things. So, because in this case, we actually define it both ways. So it's fine, either one you want to do. So I don't remember what the full name of one of these is. Asset tag ID? Yeah. Could just call it tag ID. We're not going to have any other kinds of tags, but... so there's the ID. So what we want to do is find what it is... right? We want to find which one of these goes with the ID, and then we want to return that string. So we've got a result here, and that result is going to come back, so we just need to find out what it is. Then we have the opposite version in Handmade asset, and what that wants to do is check all the names. So that's something that needs to work the opposite way, right? So that's going to go through our list and go. Now, remember... I guess we could say from name. Remember, we don't actually need this to be particularly fast. Neither of these two things is running in a critical scenario. So we can just leave them pretty cheesy. You know, like if we needed them to be fast, we certainly could make them much faster, right? And the way that we would do that is we would actually use some sort of indexing here to jump to only a set that would make sense, right? But I don't think we really have to care. Linear check of these, even if there's 1,000 of them, probably won't hurt us for most of the cases we actually care about because it's never runs at runtime. It's only an import time thing. So until we actually see it show up on the profile, we're probably fine because this is not something we're shipping to an end user, right? So let's see here. So I think what we want to do is say, all right, we've got an unknown string that will return in the case where we don't know what's going on. Otherwise, we'll run through this list of name tags here. And when we actually find one that's equal, then we return it just as we would before. So we just need to flip the ways of doing, like this one's comparing the strings. and then returning the ID. What we want to do here is compare the IDs and then return the string, right? It's the exact opposite way of checking, but the code is identical. So we're just going to do that and then return the string like so. So when we do that now, what we have to do is actually have this code be present. So the first way we do that, obviously, is just in Handmade asset, when it wants to make this call, we need to actually include that file. So if you look in handmade.cpp, we're not actually building it. That's a new file that we added. We're not actually building with it. So I need to include in my CPPs, I need to include the file formats .cpp, right? And you can see that in the H file, we've got that up here, right? It's right after random and stream and stuff. So what we want to do is put that in roughly the same area, which I guess is there, and should be good. So looking at the bugs we have in Handmade Hero, here I said string. It's not string. I don't know why I typed that. I believe it's name. Right? This is the actual field. So that, I think, is our only problem. So that's now building with the table. So the only thing we have to do now is make this code, the HHA editor, also build with the table. If you look here, it already includes some of this stuff. So I think all we have to do to make this work is just say, okay, let's include that handmade file formats.cpp in here, and we should be good to go. Now, I could put that in here because it's CPP. That's the only CPP it actually is building with. Hopefully that's fine. We'll find out in a second. All right. So in here, I think we want to eliminate this and just assume that we can do this, right? And then what we'll do is we'll just take the data out of the string here, and inside inside the actual file formats routine, what we want to do is make sure that that check that looks to see if it's out of bounds still works. Remember, the reason we had to do that check for out of bounds because we were looking up directly into an array that was indexed off of the ID. So if we had had an out of bounds ID, we would just fault, and that would be bad. But here we don't have that problem because we're iterating over a list and looking for matches. So if you pass us an ID we don't recognize, no big deal. It's just going to return the default. So we really don't need to check anymore, and this is fine, right? So we should be good to go now. Let's just take a look if we've got any other okay, so we do have to convert it to the type. So we need to change this to an asset tag ID. It's just actually a politeness cast. It's not actually converting the value. And here it wants a char star, and that's fine because it's just a string. So we can now use the same in both cases, and the reason that that's good is because, again, now for really no cost to us, every time we add something to the parser, it will also add it to the debug dump, and that's just a good way to keep those two things in sync. So now when we hit dump, we can actually see what all of these things are, right? So we can see, for example, that we've got a dark energy or a bones tag on here. And we can see that that makes sense. So hand dark bones has a dark energy tag and a bones tag on it, right? Which is what we want. Now, if I remember correctly, the reason that we thought we had a bug is because we didn't see the matching happening the way that we thought it should. And so the first thing we can start to debug now that we've added that is let's go ahead and turn back on what we thought was the problem there, which is, remember, I don't know if you remember this, we turned off these files by naming them something that our system wouldn't recognize. I'll now name them back to something our system will recognize, and all of these things should now get pulled into the system. So when I rerun the game now, it should try to import those files, right? And it looks like it did import those files. That was pretty quick, but I guess there's not that many files to import or whatever. And what you can see is it's picking at the moment, right, some ground. That's a dirt like side texture there. And again, we have the weird blue problem, right? So, you know, again, weird problems and so on, we'll have to work through those and find out what they are. Those are separate from the picking problem, which is what I want to look at now. So if I go ahead and just dump this thing to some kind of analysis file, like local .text, what I can then do is look at that local.txt file. Did I not put, I thought I put tab view in here. going on? No. I thought we put tab view in here, but I mean, I know we put tab view in here, right? What's going on here? Did I just run it directly out of the bonus pack, I guess? Maybe I did. Well, it's in the bonus pack one way or the other, so that's fine. Anyway, let's go ahead and continue what I was going to do, which is look at the contents of that dump. So here's the local HHA file. Here are the assets that are supposedly in the file. Here are the blocks. So we've got 4 of them, right? And if we open them up, we can see which ones they are and that they're all doing whatever they're doing, right? And they each have some tags. So here's what the tags are. So right off the bat, we can see that it's busted because we have these basic categories which are set properly, probably, right? But there's no other tags. So if you look in here, you can see that we are getting actual tags, right? Like there's the bones tag, and we don't have any of the other tags. So that tells me right off the bat that the problem here is actually in the import. When we go to import, we're not getting those tags. So why not? Here's our begin tags call. Here's our end tags call. And we pass the file name in here, just like we do here, but for whatever reason, we're not actually getting any parsing. So why not, right, would be my first question. Like if we go in and look at the art, I guess now that I think about it, it's actually kind of obvious. We renamed these files, cover forest, hand bones, hand dark bones, hand glove fingers. We never renamed these. So I don't know why we would think that there was any way to pick anything. That must have just been a case of me, we went long and maybe I was just a little delirious. Like, why would we think that would work? I don't know why. I don't even know why I thought something should happen there. So it looks like nothing happened wrong. That was just us being dumb and not actually even putting any input into the system. So I don't have an explanation for that. So let's take a look at what we're actually talking about here. We've got bones, dark energy, glove, and fingers. Those were our labels for the other things in the system. But now we need labels for blocks. What I would like to say is this is, it's wood, it's interior, or, maybe it's I don't know what you want to call it, like it's a structure. It's wood and drywall, I guess. So it's wood, drywall, that's what it looks like. It's interior, or man-made. It's like a wall, We should also probably have floor. So some of these tags to describe this thing, right? We'll try those. And then, again, we'll just use the system that we just made. We want to basically tack on a bunch of new words here. Here they are. So all we need to do is just actually write these in here. So we've got like a const z with the name we want and then the tag that we want, like so. So in here we could say, well, here's wood, here's drywall, here's man-made, here's wall, here's floor. Delete all those. And then we can say like wood, drywall, man-made, wall, floor. And I don't know if drywall is the right term here. I don't know what that stuff would really be called. You know, it probably wasn't called drywall back in the day either, when, you know, in mythical times and so on, when you think about when this game might take place in a mythical kingdom, I don't think they were like, oh, and what ho, good sir, please to come across your acquaintance, and would you like to do some drywalling? Like, I don't know that Shakespeare had drywall. I mean, maybe he did. But they probably had a different name for that, so I don't know. Not exactly as sort of mythical world as you might want, but you know, no one has to see that, so it's fine. And that's will give us what we need. So if we then go in here, we've got sort of these block orphanages, and there's a stone one too. So maybe I'll throw that in there too. You know, we'll get a stone in there, like so on, and that'll be a good set of stuff. So that's like a stone floor, and probably a man-made one, right? They're very regular. So I think that's fine. I can't think of anything else I really need to do there. So let's just go ahead and rename some of these to something that actually will work for us there. So we've got this block forest. I guess, you know what, now I think about it, while we're at it, let's add that one too. So this is like there's a grass kind here, and maybe so I don't know if floor, so I don't know if we want to differentiate between floor and ground. I don't think we do. I think something is probably just man-made or not, right? And then it's like floor or not. So if something's a man-made floor versus a non-man-made floor is probably sufficient, would be my guess. So I don't know, because there's two ways we can look at that, right? And that's that like man-made is a tag and natural is a tag, and floor and ground are both tags too. And you just throw all these tags in there and let someone sort it out, or you try to be minimal about it. I don't know which one we want. It might be that it's better to not try to be minimal about it. You know what I mean? And yet another way to say that would be maybe we want this thing to actually have more of a like settings sort of a structure. So just to give an example, you know, suppose you were to say tag ID from name, and it returned you a value as well. So it could be that, like, you know, man-made is like man-made 1, and natural is man-made equals 0. Like, you have the tag and its value is something. You know what I mean? And so then when you say tag name from ID, you would actually pass the value in, and it would tell you what the meaning of that thing was in another way, right? I don't know how I feel about that. When I'm looking at these right now, I don't know. We'll have to see as we go. Again, I'm okay with updating the system one more time. We have all the source assets, so re-importing everything is not a big deal, so we can play with it a little bit and be a little bit more flexible if we want to, right? So looking at this here, we've got a couple more we want to add there. We've got wood, stone, drywall, man-made wall, floor. We want to add that grass in here. And then I think we've got the stuff that we need for naming. This does not really have to be forest. It can just be kind of like block, floor, grass, right? This is going to be block, wall, man-made wood, drywall. This is going to be block, floor, man-made stone. And this is going to be block, floor, man-made wood. And these are like, you know, doing their thing. And now when we input them, they will have some tags that can actually be used to like pick something, right? So I think that's all we actually had as a bug. And I would point out that we actually can, if we want to, like when we're doing this, we don't even have to be pristine about it. It's wasteful, but if we just rerun, all that's going to happen is we're going to get some more blocks, right? And so if we then look and redump that file to a text file again, and I reload it here, what we'll see is we actually should have just stacked up more assets, right? So we don't actually have to go redo. We can leave bogus assets in here. It doesn't cost us anything but a little bit of extra space. So during development, we don't have to care that these things are in there wrong. And the fact that they don't have any tags means they're never going to match anything anyway, so it really doesn't matter. If we want to take a harder line on that later, we can, but right now it's our purview to just leave them, right? What we see here is, oh, you know what? I didn't recompile the file, so that actually is not good. Right? I don't think I actually built this. Yeah. So now it should be looking for those tags, right? And now when I actually run this, in theory anyway, so now I actually do have to do it because we haven't touched those files, right? We modified the code and haven't touched those files for parsing. We could rename them or just do a touch on them to change their dates, and then they would get re-imported potentially. I think I'll just rebuild the HHA because that's easy enough for me to do. So if I go in here and I just delete local HHA, and then I do a HHA edit, I can do a create local.hha, and now we have a new one. It will re-import all of our stuff cleanly and build a fresh pack, right? Now, in theory, that imports so quickly. I guess the optimized build is just, hey man, computers are really fast nowadays, so even though we haven't done any work to actually make, to make that fast, it just is. So there you go. Oops. And so looking at this now, we can see their tags. We can inspect it and make sure the tags are actually correct, because that would be nice here. So we can see that, like, here's our block for the wall, and it is a wall. It's man-made. It's wood, drywall. That's good, right? So all that stuff's in there. And so now when I run, in theory, I should be able to, like, actually control some of this stuff, right? Now, we have some issues, though. There's one more issue that I'd like to tackle before we really try into that, because we're going to end up with problems. So let's go. We'll write a little bit of code to kind of decorate, like make the world actually pick the pieces that we think it should be picking. But then we have to go and figure out what's wrong with our color swapping, and then we have to decide what to do about the upside downness, right? So we've got some more issues. Like, we're not really done with the importing yet. We've solved the tag issue, which was that we never actually named the files. Oh well, like we were crazy last week. We weren't thinking. So we thought there was a bug. There really wasn't a bug. We just never actually named anything. And that's fine. It's a good bug to have as a non-bug. So anyway, let's go take a look at what we would need to do for the entity tagging stuff. So what I need to do here, if you notice, we have in here, there's sort of this notion that an entity has, you know, all this stuff that we haven't really talked about or done anything with. We just throw things in here, and that's exactly the way I want it. I don't want to work on the entities until we're pretty much like halfway through the game, right? Like when we're actually kind of starting on gameplay stuff now, in a sense, like we're making out the world. So we will start paying more attention to entity structure, but again, I don't really want to do anything to clean this up. This is supposed to be messy, but we do need to add a piece of information to it, which is what tags this entity has. So we need to have a tags system in here that allows us to tag these things on here, because right now the only thing we have at the moment is we just have the asset basic category, right? Which is not what we want to do. So what we want to do is have some more tags in here. We want to say, okay, we've got asset tag ID, and we've got some tags in here, you know, and the entity has some tags. You know, I don't know what they are, but the entity has them, right? And so I want to put that in there. I also want to look to see, is smoothness used anywhere? Smoothness is not used anywhere at the moment. So you know what I'm going to do? I'm just going to go ahead and go rogue and say that tag 0 is actually just none, right? So, because, hey, we can. So I'm just going to say that tag 0 is none. It gets skipped. So smoothness, which was some random thing we put in there, is now no longer in there. Sorry, anyone who was tagged with smoothness. We'll make another smoothness later if we have to. But these tags will go in here, right? And then what we'll do is we'll say, all right, when we loop through these tags, we will unpack them into whatever the asset matching vector is, and we'll go from there, right? So what I want to do is the way we're currently matching is not particularly useful. So there are some issues there. Well, okay, let me talk about a few more things. So there is one reason not to do what I just said, and this is probably why we decided not to make there be a how should I put this? There is one reason why you might not want to make 0 be none. And that reason, and is probably the reason why we didn't do it in the first place, which is that if you want to expand these things out to a vector to match, then you want each of these to correspond to a position in the vector, right? So you have like 0, 1, 2, 3, 4, 5, right? And you don't want none taking up a slot. Based on the way we're talking about tags, I have changed my mental model of what these things would be, how a matcher would work, because if you look at it, we're going to have a ton of tags. There's going to be like 100 tags. So we're never going to want to build a vector of them. We're going to want it to remain sparse, right? And so what we want to do here is just do something where we like sort the tags or something, right? And then compare them to each other. That's all we're going to want to do, I think. So if we sort all of our tags and like in ascending order or something, then we write a matcher that works that way. That would just solve our problem. And so that seems like more what we would want to do to me, right? And so I don't care about, I want none to be 0 now, so that way we just have an easy way of saying that there is no tag there. Okay, so I want to put in a tag array like this, and then what I want to do is match against that tag array. And I want to get rid of the way we're doing the matching. So we want to kind of update the matching a little bit. We'll leave the matching the way it is now, and we'll update it to something else another day. And so I'll put a to-do in the code in the entity system for making it work that way. But at the moment, I'm just going to go ahead and, oops. At the moment, I'm just going to go ahead and make it so that the entity uses the same matching as it used to use, because that's more of an optimization thing, and I want to put, I don't really want to go and deal with that right now. We can deal with it a little bit later. It's not going to, it's just going to be a performance cost, really, that we definitely don't want to pay as it gets higher, but it's not going to prevent us from doing the work that we're trying to do today, so I'm going to punt it to them. All right, so inside update and render entities, when we come through the entities here, what you can see is that we eventually have to do some stuff where we do some matching. And so here's our way that we were doing matching, and that's all fine. But what we want to do now is make sure that our tags are actually expanded in here. We've set the facing direction in here, and that's fine, but now we also want to say we want to match on some of these other things. So let's go ahead and loop over the things in our entity tags that are actually what we want to match on. So I'm going to go ahead and say, like, here's a match index is less than array count, you know, entity tags, plus match index, and then for each of these things, I want to say that the match vector of the entity tags match index, which I could pull out, right? So I could say, like, okay, asset tag ID. So I'll just say the match vector for that is going to be whatever the asset has. So I guess now I think about this, I also need a tag value, right? So in here I need a tag value. And these two probably should be paired together, right? We'll probably want to do that. But again, I want to clean this up a little bit later. And so here I'll also put this. something like that. So what I want to do now is say, okay, we got a match vector for this tag. We want to set it to whatever the entity's tag value is for that thing, right? And then we also have the weight vector, and for now, again, we'll just say, okay, the weight vector for the the weight vector for that thing is going to be 1. So it's just uniformly weighted all the way down. But we might want to change some of that later. So anyway, what this does is this unpacks the entity's tags that it's got into a match vector for use in the system. Later on, we'll just leave them packed and match directly on the packed version, but that's all there is to that. So what I want to do now is actually add those tags to the entities somehow. Because right now, entities don't have any tags. That's just not something that they actually have. Oops, sorry, this is an E in those cases. And so what we want to do is give our entity some tags to match on so that we can see if the matching is working correctly. And so if you look here, right, like none of these entities have any tags, so none of them, it doesn't know that's a wall, it doesn't know this is a floor, blah, 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 right? So what we want to do now is when we actually create the rooms, in here we create entities, right? You can see us placing these entities. Here are the entities. What we want to do is set those tags on the entities and work through those. Now, I don't know exactly how we want to do that, so we'll kind of just rough it in right now, and then we'll add some more stuff later. I probably want to maybe, just looking at it, I probably want to be able to do something like this. So I want to be able to say, like, let's add a tag, and let's say, is this thing a floor? Is this thing whatever, right? And so in here, we must have known that, right, because we were placing the things. So when we come through here, we can say, like, okay, is it on a boundary? Is it on a connection? Whatever. And so when we look at these things, we should be able to say, is it a floor or not? And you can see we're kind of already doing that. If it's on a boundary and not on a connection, then it's a wall. So it should add a particular type of tag. And then we need to add one of these traversals for it, right? So I can put that in here, right? Like so. But I can add a tag one way or the other, right? So this is going to be a wall. And this is going to be a floor. And what we can do here is have the floors be, we can change which kinds they are at some point. But what I'm going to do now is just say like wall or floor. In any case, everything in here is man-made, at least for the moment. So we're always putting a man-made one in here. And again, all of these things have to become more complicated because this room gen generates our outdoor rooms right now too. So we obviously don't want that. But we'll cross that bridge when we come to it. Right now, we just want to make sure that our tagging system can work. So that's all we really need here, I think, is to say these couple of things. We should probably say what kind they are here. Maybe this is a wood floor, generally speaking. We could also say that in general, this is just wood construction. So we could put that down here. And so that just sets these tags up to work. What that means is that in here, we need a thing where we actually say what the tag count is, like so. And if that's the case, then in here, this should actually look at a tag count like that, right? And what we want to do then is just have a thing that when we call tag count, when we call add tag on an entity, that actually does something. So for example, in here, we can actually say add tag. Now, I think we decided that doesn't really go in entity, I guess. It goes more in world construction because that's where we add things like pieces and tags. I don't know if that makes a lot of sense because it seems to me like this stuff will have to migrate out eventually because it has to be something like we want to add IDs and pieces at runtime potentially. So I feel like this stuff is probably inappropriately placed in RoomGen. So I think we'll have to move it out to something more sensible later, but that's okay. It's not really a big deal at the moment either way. So here's the tag value that we're going to add, and there we go. So the first thing we need to do is just make sure we still have room. So we have to make sure that, for the moment anyway, because the way that we're doing this is, again, kind of a little ad hoc, since the entity structure is something that will be dealt with much later on, like when the game is playable and partially done, right? So we want to make sure, though, for the time being, that the fixed array that we're adding it to has enough room. And then when it does, we can just say, all right, the tag index is whatever the next tag is. And then we just set the two values. So this entity tags is going to be this ID, and the value is going to be this. And so then we've got a way to stick the tags on the entities. And so now we should be able to debug a code path which essentially selects various things in our game from the options that are presented. So what we want to do now is make it so that we can see when these entities go through that system, are they getting picked properly? If they're not getting picked properly, why not? Now looking at it, it doesn't look like they're getting picked properly because everything still looks like it's picking just a ground tile, right? It doesn't look like it's picking anything on there. And so I want to go in and see why are we not picking. Now I'm going to go ahead and downshift to debug mode here. So I'm going to go ahead and say, look, give me just the debug version of the code. And when we go through here, I want to see why we're not getting the matches that I think we should be getting. So I'm going to stop in here and I'm going to look at an entity that has some tags. I want to see what those tags are and just so we can see like what we're actually matching. And then I want to look at the match and see is it matching properly or is it doing something stupid. So here's an ID. It says it's a floor tag, right? I don't want to really match that. I don't want to, well, yeah, well, let's do it anyway. So what's the value here that we added? Match vector. Weight vector. So let's see here. We got a match vector and 18 is set, right? We got a match vector and 18 is set in the notch as well. And 18 is our floor value. So that looks correct so far. We come in here. We're going to set another one. What's the one we're going to set? We're going to set the wood tag. There it is. And then we're going to set some other thing, man-made. All right. So we're going to set man-made wood floor. That's exactly what we should have set. So we now need to know why, why aren't we finding that? So when we go to get best match, what's the deal, right? Why aren't we finding anything? So let's look at the tags that are on this actual asset. Here we find a tag ID of 8. I don't know if Visual Studio can do this. It can. So that's the basic category. We don't need to match that one, so I'm assuming it will just get rid of it. Yeah, which is good. Then we've got another tag in here, 18. Let's do it that way. So this is a floor tag, so that should give us a weighted, and it doesn't. All right, so what did we screw up here? Because this is a floor tag, we should be matching on floor. Oh, it's a difference. So it should give us a difference of 0. Yeah, that's what we wanted, right? Yeah. Okay. I think I see the problem here. So the problem is that the way, again, the way we were doing this matching is just kind of dumb, right? So the way we're doing this matching is we only match on tags that the asset actually has, which does not work. Because basically if an asset doesn't have it, we don't count it as a penalty that it doesn't have something that we were trying to match on. And it should, because something that doesn't have it should actually count against it, right? So I feel like that's just kind of busted. So I may have to update the tag matching early because I'm not sure how else I would go about fixing this problem. I could sort of hack a thing in here which would look for things in the match vector that weren't there, or I could switch it to a positive match. I guess I'll switch it to a positive match for now rather than rewrite it. I guess I'll just switch it to a positive match for now. So what we're looking at here is the best difference. So we look for things that are the lowest. I'm going to change it to looking at things for the highest. So what I'm going to do instead is say that, right? And we'll start out at 0. And when we loop through these assets here, what we do is we say, all right, what is the total match? We go through and we say, for this one, we'll say for the match vector, I can convert these to our new type naming here. We look to see what the absolute value is of the difference between these two. And what I guess I want to do is I want to invert that. So we say, here's the absolute value, here's the not sure what. Oh, interesting. So we have a tag range. That's very interesting. So we actually have a way of mapping the range in here. That's even more interesting. All right. Well, I wasn't expecting that. I don't know if we really need that, but we probably did that so that we could have directions work properly, like the facing direction. It's a little more advanced than I thought we were being in here, but that's okay. So when we actually take the difference here, what I'd like to do is just say, look, let's go ahead and say that whatever the difference between these two things was, we want to give you points for every one that you match, right? So we want to say that you effectively do something like this, you know what I mean? And when we then weight those things, we add together the total match value, and then we look at whichever one is highest, right? And so it's just a way of saying that if you have more matches, you'll get more points, rather than just saying we're trying to minimize the number of times you don't match. And I think that will solve the problem temporarily, but like I said, we kind of want to look at this in a slightly different way a little later on. Okay, so best match, sorry about that. Now let's see if we get a little bit better matching in the short term here, just so we can finish kind of what we were doing. So that's exactly what we wanted to see. So that's much better, obviously. And so now I think we at least know our tags are working, and we now just have a problem where we've sort of got a we know we've got roughly the right thing happening, but we have some obvious import errors. The upside downness and the blue tinge we now want to look at, because we're in the pipeline for importing and selecting assets looks like it's working properly to me now. And so we want to kind of switch to looking at that. And I'm not sure how we want to address that. So the first thing I want to do is look at our render test, because our render test does not have this problem. I want to make sure that our render test is actually accounting for it properly. So I just want to look at what's going on here. So if we look at what's happening in our loader here, when we load the bitmap, just looking at how we read it in, the bitmap might already be bottom up, so that might be solving this problem automatically for us here. Actually, but let's take a look. So in here we've got our red, green, blue. We're packing it in so that we've got A on top, R then G then B. I thought that was how we were using the import here as well. So I'm a little weirded out by why we were getting a blue shift in our current stuff and not this one. Because inside the loading here, that should have been fine, right? So you can see when we load things out, we've got a, we do have a swap R and B. Let me look at what happens in there. So in there, we basically take the existing color and we just swap what's in those two. That looks pretty sane. And I do think we should have to do that, right? Because the PNG would be encoded. And I mean, you could see us loading it here. We're loading it that way as well. Although I guess this isn't loading a PNG, it's loading a BMP. So let's look inside our PNG reader. What do we do here? Because I'm pretty sure it should come out like with like the order RGBA, RGBA, because I thought it was, I didn't think it was Windows style. So when we actually output this, we don't swap it or anything, right? Just want to see what we're doing here. Here's our parse PNG call. And we just call parse PNG. Like that's the only thing that we do to it before we start working on it, right? So if we look in here and we look at what happens during parse PNG, it's just that loading routine we just looked at. So it decompresses the bytes, does the consume bits, compute Huffman, blah, 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 right? Does all the work to decompress the PNG, and it just outputs the data, right? And when it calls PNG filter reconstruct, it doesn't swap any bits, right? Yeah, I mean, I don't see anything in there that's doing swapping. So I would expect them to be correct in that RGB order, which means we do have to swap them, right? Like they should have to be swapped. And so, yeah. So what's going on here? Here's our thing that extracts the image, right? There's nothing particularly weird about it. It's pretty straightforward. It just converts, it does a alpha pre-multiply. Other than that, there's nothing remarkable about that. And then when we do our downsampling, downsampling doesn't do anything weird, right? It just blends these together. So yeah, I don't really see anything weird going on there. I don't see the problem. I don't see what's up. Something's up, but I don't see what's up. When we actually go to submit these, I'm assuming that they just get submitted directly through. So yeah, I don't know. So let me just verify a few things first, and then we'll figure out what our next step should be. I'm going to launch Nsight. And I'm going to run Handmade Hero through Nsight, like so. And all I'm going to do here is take a look. Looks like we're running in the wrong directory. Okay, do I have to save this somehow? I don't really know how to save it, but that's where we actually want to run it, right? So if I launch this, what I want to do is look at what the textures we actually downloaded are to make sure that the textures themselves are tinted blue and it's not a rendering artifact, before I go chasing down a bug that doesn't actually exist, if that makes sense. So what I'm going to do is do capture for live analysis, let NVIDIA capture the frame. Then I'm going to go look at our texture set and see what the textures actually have in it. So what I could do here is, let me just go ahead and make this a little bit bigger. What I can do here is just say, look, give us something like where we render something, you know what I mean? Let's go ahead and scrub for something like that. So there's some, I don't know why they're all kind of over in the corner there, but if I look through our render passes here, we should be able to find one that's mostly geometry, and I think that's probably one. And so if I look at what the textures are that are in play here, I should be able to see something. Like some kind of texture array. But I guess the other thing I could do is just look through the total set of textures. In fact, that's probably the easier thing to do, so maybe I'll do that. There should be like a way to look at all my textures, right? There it is. So if I look through the textures here, there should be one of them that's like a texture array, and we'll see which one it is. So here it is, right? And so what I want to do is go look at and see like what I actually downloaded. So if I look at this tile, that pretty much tells me what I need to know. So the R and B channels are swapped in it. And again, I don't know why, right? I don't know why they've been swapped. If I look at the rest of the, how do I get out of this? Do I just do that? There's got to be a way to change the array slice, right? I would think. That's a histogram. How do I change the array slice? Okay, so I hit the right mouse button is what I just did there to change the array slice. So looking at these, you know, I can see that it's not really a problem with the texture upload because these assets that came from the previous import path, they're right. So like that doesn't have its R&B flopped, but this does. So the question is how's that happening, right? And I have no idea. So let's go ahead and look into it further. When I go to submit a texture, let's see what's actually happening there. So if I go to the Win32 renderer for OpenGL, when we do a text subimage 3D, which is how we send these things down, if I look at what's actually happening in there, you can see here that we are passing the BGRA extension, right? So that means that the order of bytes that is being passed in the data field there should be blue, green, red, alpha. So the low is B, then the next is G, then the R, then the A. If we go and look at where that call is actually made to submit the texture, that's going to be in Handmade asset. And we're actually going to have a thing for finalizing the bitmap, right? Here's where we pass the bitmap memory, right? We add an op to the texture queue to do that after it gets loaded, right? So this is what does that work after we do the read from file and we're done. So we're not like modifying the data in any way when we pass it down. We're just passing it directly. So it pretty much just leaves us with the import, and the import has got to be mucking with it somehow, right? So when we call parse PNG, and we are pretty sure that the PNG has those things flipped around, right? But I guess, I don't know. The other thing could be that we don't, that's not true. PNG byte order. Colors can be represented by either grayscale or RGB. Grayscale data represents luminance. RGB data represents calibrated color information or uncalibrated device. All color values range from 0 to most intense. Yep. Sample values not necessarily linear. Blah blah blah. Source surface not necessarily. Okay. Red appears first, then green, then blue. So it's RGB. Right? So I still don't see any reason why this thing wouldn't be coming in as R first, then G, then B. We'll have to step into it and find out. But let's assume that's what's going on. We go to process multi-tile import. Let's just see what's happening. So when we look at these, we're scanning over and we look at the alpha channel. That we know is in the right place because we're not getting any bugs there. So when we come through here and we look at these pixels, and no one has done any swapping, this is just the raw input image, right? There's nothing has happened so far. So when we come through here and we do a downsample on this, and then we do a write image to HHA, those are the two places that this stuff could get mucked up. I'm going to look at the write image to HHA function, just see what that's doing, to see what's actually happening in there. So looking through here, we don't touch the pixels at all. So it can't be happening there, right? I want to look at BGRA unpack and make sure that that's doing what I think it's doing. So BGRA unpack does what I would expect. RGBA. It unpacks the V4 as I would expect. BGRA pack 4x8. Also looks correct. I mean, I can't say I see anything odd, right? It all looks fine to me. Yeah, so I don't see anything weird happening there. What I will say is I don't understand why we did it that way. Like, we don't need to do what we're doing here. It seems just kind of dumb. So maybe I will change this a little. If we're going to debug it, we might as well debug a smarter version of it. So when we actually... Oh. You know what, though? Here's the thing. We don't call this path. This only happens on multi-tile. So I think all we're really seeing is the fact that when we actually call one of these process single tile imports, we don't actually call that. So I think the problem here is really just that. Yeah, that's not sufficient. So I think what we want to do here is probably do the flipping and the color conversion in probably a more uniform way. I don't know. It's a good question. Let's start with a few simple things. So if we're going to convert this, I think we should just do an RGBA unpack on this, because that way it'll unpack that and then pack it into G. Like, we don't need to call the swap separately. So we'll do this. We can also flip the image to be the correct orientation here, because when we're writing in the desc pixels, what we could do is just write into the desc pixels backwards, right? And or read from the source row backwards. So it's our choice. So maybe we'll just do this. When we're flipping through the source row, we'll just say, look, instead of starting at the top, start at the bottom, right? So instead here, just say go to max Y, right? And start there and read from the bottom back, right? And I think that should be sufficient for handling that path. But then we need an equivalent path in the other places that we were dealing with this. So in here, where we do process single tile import and process plate import, those also need to have some way of handling this problem, because they don't go through this extraction path, right? So what we probably need to do there is sort of make this a little bit more regularized so that this actually works properly for everybody, right? Before the downsample is called. And we could bake it into the downsample, but I don't think we really want to do that. So what I want to do is, like, you know, extract image, something like this. And then I want this to happen inside there so that everyone can use it. And go from there. So let's just try doing that here. So let's suppose in here we say that there's this extract image call. And everything that's going to be done will get done every time by the extract image call. So it'll flip and change the RGB the way we want it. It's a little bit of an open question whether we want to do that at all, because another thing we could do is switch to the RGBA ordering, which is the more normal ordering. And so we should have that discussion as well. Because now might be a good time to do that. And so what we would really want to do there is just go ahead and set up a re-import for all of our cutscenes as well, and then just do one big rebuild of all of our HHAs for fonts and everything. And then we can just have a clean slate that we start with. And we're not far from being able to do that, so we probably should. And so we should think about that at that time, because really the BGRA is a Windows anomaly, and we probably shouldn't keep it inherited now that we don't really need it for anything. So in here, what I would say is, okay, we've got, we need that temp arena because we need to be able to push this temporary buffer on for doing this work here. What we want to do is say we've got an image U32 that's the source image. That can all stay the same. All of that information can stay the same here. We can return the tile image like so. And I can call this result now. Oops. Right? So we make the result here by saying extract image, do all this work to it, and so now we really just need to know the bounds that we're actually using. So we say like min x, max x, min y, max y, right? That's what we're extracting. And so maybe I'll do min, min, max, max, and off we go. I think that may be all we really need here. This computation really, though, has to be done on the outside. But other than that, I think we're good. Right? So when we call extract image, we're just going to pass a temp arena so it can do its allocation. We're going to pass the source image that we're extracting from. And then we're going to say, like, look, here's the min and max y that we need, and the min and max x that we need. Oops. There we go. So what we want to do is pass in here for the x and the y, just our min and max values that we actually want here, right? So here's the tile base, and here's the min and max extraction inside the tile base that we want to extract. I think that gives us what we want. When we go to downsample, I'm sorry, not when we go to downsample. When we go to call extract image for everybody else, oh, and this is tile image here. They can do the same thing now and do the extraction that will do the flip upside down, right? So this will be like a prep image call, like so. And we will downsample that prepared image instead of the source image. So now when we go to do this, we know that when we actually do the process plate import, all we have to do is say, well, we want the whole thing, right? So it's just going to be 0, 0, and then whatever the source image's width was and the source image's height. Now, the only thing I don't like about this is that I feel like we should be passing one past the min and one past the max, because otherwise we're going to do this here, and I don't like that because that's very error prone. It could produce bad outcomes, like by wrapping the value if it was 0 or something like that. So I think we may want to do something where we say, okay, let's modify this routine slightly so that when we come through here and do an extract image, we're really just going to get rid of these +1s here, do it like this, and so we're going to do a subtract 1 when we actually grab the value there. So that should be fine because we won't loop over anything if we have a 0 in these cases. And so it won't matter what we put in here for the source row because we'll never read from it. So I think we're okay, and I think that's probably the way it should go. So it's really this. You know what I'm saying? And I think that's a little bit better just because of the way the math works out there. So then when we pass this in here, all we need to do is just enlarge it by 1, which is safer for us to do. And then I think we've got that import path worked out much more cleanly than it was before. That's all irrelevant now. It's all welded in, right? And I think we are good. So in here also, I think we passed source image. It's not source image. There is no source image. It's just image in there. There we go. Okay. So temp arena here looks like I put that as the last parameter, which I think is good. It's the destination, so I tend to put destinations last, so I'm okay with that. We'll just say that that happens here. And then I think we're done with that whole path. Yeah. So let's see now what happens when we re-import. What do we get? So if I delete the local AHHA and I create a new one, so I'm going to force the entire re-import path, which is so much slower in debug mode. I guess I never realized quite how much the optimizer helps there. But I suppose all the PNG reading and the flipping bytes and everything just gets a huge win from the optimizer, which is cool. But it should force the re-import everywhere, hopefully. I don't know if it does or doesn't. Let's see. Looks reasonable. So I think we're just going through, doing all the downsampling. Hopefully everything's working properly. All right. So now what I'm seeing looks entirely correct to me. Let me go ahead and switch to optimized build here. What I will say is that the lighting is a little bit, the lighting mapping it's a little blown out, right? We need to probably work on our lighting, which we knew was true ahead of time, so that's fine. But it's looking correct now, right? We're getting exactly what I think we should be getting in terms of how these assets are getting picked, so that's good. And we should be able to now differentiate like two rooms, right? If we wanted to do that. So, you know, if we wanted to have an outdoor area be forest-like, we could do that. And if we wanted a dungeon to be dungeon-like, we could do that, right? If we wanted these areas to be stone. So I think we're now pretty much clean with how the assets are getting picked. So if I go ahead and switch back to the room gen, for example, I think that's probably all we really need to know. Now, when we look at the gen room structure, right? So, oops. You know, inside the gen room structure, we don't have, like, this room spec thing doesn't really have any information about what should be going on in here. But we could make just a quick modification to it just to figure out whether this thing is working at all. And we could just say, like, look, does it have a stone floor or not? Probably not how we would want to do that normally, but we'll just say, look, that's a thing. So then when we go into the gen room, we can pull out the spec. So in here we can say the gen room spec for whatever this room is going to tell us whether it has a stone floor or not. And so in that point, what I can do is say, look, in here, we know that at the moment, if it's a wall, it's always wood. If it's not a wall, we're actually going to set whether it's wood or not based on whether the spec says that it has a stone floor. So we'll say that the floor is stone in that case, and off we'll go, right? Now, if we run this, we shouldn't see anything happen because we'll never have set that. So it should always be false, and we'll always have the stone floor flag set to false, right? But if we were then to change and say, well, when we actually go to build the world, let's give some of the rooms stone floors, then what we can do is say when we actually made those dungeons, right? You can see in here we've got like the bedroom spec. We generated a spec there. We could say that we want the bedrooms to have stone floors. That's you know, just what happens. Because these are orphans and they're mistreated. You know, then when we open it up, we should expect to see bedrooms having stone floors, right? And then we can test it, and they do, right? Now, these are the heroes' rooms, which is also technically a bedroom, but they don't get stone floors because that's a save slot spec. So we could make the save slots have a different kind of floor. But, you know, if we play the game now, we see that there's stone floors in those rooms, right? Which is what we wanted. So I would say really we're right where I want to be. So the other thing is it's a little repetitive here. So if you look at these, you can also kind of see that the floors are not, they're all the same tiles, but they probably shouldn't be. So there's one other thing we can do there too. Which is in the room gen, right? When we go in here, the UV layout for these cubes is not being set. So when we actually want to set this, I believe inside the add piece structure, right? Sorry, that's in here. So when we do an add piece, you know, it doesn't set anything about that UV mapping. So what I want to do is say, well, when we do an entity visible piece and we add one of those here, I would like to be able to set the cube UV layout in situations where I think that's appropriate. And so one example would be like, if I want to do a randomized top, right? So I could say true on randomized top. And if I want to do true on randomized top, you know, I'll just set this cube layout. If you remember how this thing worked, we can pack UV layouts here. There's like a default packing for each of these things, right? So when I want to do this, I want to say there's a bottom index. I don't care what it is. I don't care what the facing index is. There's 4 side indexes. I don't care what those are either, right? So these can all be zeros. But in the top index, I want to randomize. So I want this to be a number between 0 and 3 that says which one it is. And furthermore, I could randomize its facing direction. So I could just totally randomize this if I want to. Just again as an example, not something we want to do exactly this way, but something we can spec. So when we look here, I can set a random, by using the generator entropy, I can come in here and say, look, give me an entropic value that I can use to set this. So I believe we have a concept of a random count. So we can just say like, give me a random count of 4, right? And so set the facing direction randomly and which one of those 4 tiles you're using randomly as well. I don't know why I deleted the A there, but I did. Okay, so maybe we don't. Don't we have a random count? Random choice. That's what it is. Sorry. Naming nomenclature problems. So off we go. And now what I want to see is like if we, well, I'm not seeing it, unfortunately, so that's not good. But what I want to be able to see here is I want to see some variation in these, and I'm not seeing it, so that's not great. When I look in here, I've got randomized top set to true. Oh, that's for, oops, that's for the walls. So it is working, actually. You can see they disappear because there isn't one in that part of the wall. My bad. Try that one more time. So this should randomize both the orientation and the selection of which one of those wood grain floors it uses. And so now that's working. You can see that happening here. And I don't know that, like I said, we don't necessarily want that. I just want to make sure it worked, right? So we now have the ability to decorate our rooms however we want to, and that's good. And we can go from there. So that all seems nice. And I think that's a good place to leave it. Next weekend, we'll start to kind of go a little more crazy. I don't necessarily love the color variance here that's happening. There's a lot of color variance there. I don't necessarily know why. I think it might be because, do we have randomized color perturbation here? We don't. So that's actually coming from the like reflective, oh right, because the walls are like red and the ground is green. So we're actually seeing all those bounce colors. Well, no, that's not true. So I don't know why that's happening. I'm not sure why we're getting those bounces, because that's not actually what's happening there. If I was to turn this off, we would actually have the old colors come back, and we probably want to fuss with that as well, but right, yeah. So I don't know why we were getting some of that coloring in there. We'll have to look at that. Again, the lighting is something that now we have to take more seriously, and that's something we're going to have to get working better. In this case here, I guess what I would say is maybe we just want to back off on this reflectivity a little bit. But we need, we also don't have roofs, which is another problem, because then there's nothing for the light to bounce off of. So we got issues. I'm also not sure why those are transparent. Oh, gosh. You think possibly the fact that you set it to transparent could have something to do with it? Just maybe. All right. So yeah, so we've got a lot of work to do on our sort of rendering side of things now to clean all that up, but we're pretty close now. Right, let's do one more thing. We can set grass. Sorry, let's walk in here. Yeah, everything looks pretty good. So I think really we just need to improve the lighting, which we knew we had to do already, distribute sample points well, and clean up the algorithms a little. But we're looking pretty respectable. Yeah, I'm pretty happy with that. All right, probably don't have much time for Q&A here. I gotta go today, so I'll just take any really quick questions about what we did. If there's any specific on-topic questions, I'll take them, and then we'll close it down. Will you update the test asset builder to version 1? I think what we'll probably do now is delete the test asset builder and roll the font thing into our game code. Well, not necessarily game code, but maybe the HHA thing. So you can just insert a font into it. Because the only thing, the test asset builder we don't need anymore, so I'd like to just get rid of it. You know what I'm saying? So what was the reason for the blue? Oh, so the reason we were getting the blue was because nobody was doing the swap. So remember, we have a couple different import paths because we have different formats for our assets. One of the assets types is tiled, right? And in the path that we extract tiles from a PNG, we were swapping the RNB. But in the path where we took the whole PNG and put that in as a texture itself, we weren't swapping. So it was just a case of we needed to unify the paths to do manipulation of the PNG always, no matter which path we went down. So that's why I pulled out that extract image function and made it so that everyone calls that first, because that way we know that we're not going to get any of the paths accidentally not flipping. Will you write any unit tests to cure yourselves? So when I said on-topic questions, I'm wondering how someone thought that was an on-topic question. But I've talked about unit tests many times. You can search the archive for it. In short, they're not very useful for games, except for very specific situations. And occasionally you do want to unit test those. You know, like things like a memory allocator or trying to think of other typical ones. Job system, memory allocator, these things can often be unit tested a little bit. There's a couple of things that can be unit tested. Most of the time, you can't, right? And the reason for that is because games are about random player input. And so typically what games do for testing is not unit testing, because unit testing it only helps you find bugs that aren't really the hard bugs. What you typically need is simulation-based testing. So for example, one of the things that games usually do, at least at the higher end, you know, if you're a AAA game and you got resources, they make randomized testers. So these are things that play the game randomly. They like simulate a player sitting there just doing random stuff. And they try to find sequences of inputs that will produce crashes or allow the player to get somewhere that they've marked the player shouldn't get, you know, things like that. So typically, if you want to map it onto something from like other types of development, it's more like fuzz testing. Input fuzz testing is more like what finds bugs in games than unit testing. Unit testing is not usually relevant because most of the code for a game doesn't have a well-defined input and an output. It's about all these state transitions that happen, and you're trying to find errors in the state transitions that only happen when you do some set of inputs, and you don't know what that set of input is. You can't make a unit test. You have to generate randomized testing. So you can still consider that a unit test if you want to, but it's not the kind you normally think of where you're like, let me brute force all the inputs to this function or some set of inputs to this function and make sure it has the right responses. That kind of testing is fairly useless in games. The only kind of bugs those will find are bugs you probably would have found anyway. So you really need, if you want to try and be robust, is you need the simulation-based testing. And that is very valuable. If you have time to do it, I highly recommend it. But it can be very complicated to write. It's much harder than unit testing. That's why a lot of people just rely on play testing, right? That's the poor person approach. I've never streamed, so I'm not sure what's going on, but why are John's streams left in the videos tab and yours aren't? Oh, because I just, I don't set that option in Twitch. I only put the things in the archive. All right. Will you tile the fonts as well then? Possibly. I think we probably should. There are two routes we can go with that. And I don't know which one we should take. One is we can tile the fonts, and the other is we can just have a separate array for fonts that's small, fonts and particles. That might be the smarter approach. And then what we would do is we batch those together. So we set the texture array once, do a whole batch of font rendering, unset it. You know what I'm saying? So hard to say. We could take either approach. I don't know which one we should take. But, you know. So we'd have like a 512 by 512 texture array and a 64 by 64 texture array. All the fonts and the particles go in the 64 by 64, which has a lot more, right? Slots, that kind of thing. All right, I'm gonna wrap it up. Thank you, everyone, for joining me for another episode of Handmade Hero. It's been a pleasure coding with you, as always. We are now at the point where we've got to start pushing that sort of world gen stuff a little bit more. So we're going to kind of try to pull all these things together, and that's going to be a fairly lengthy process of like building out the world. And we need to take that in a couple of waves, right? So first thing we want to do is start to put the art assets where they belong. make sure our systems for doing that work well and we're comfortable with them. We need to add some nice abilities in there that we don't have right now, like the ability to spread ground cover around and things like that. And then we need to also tie the lighting in. So the lighting is still not finished. We need to bring that in, get it looking right. So that's our next goal, is to make that all happen. Once that's done, we've kind of got our game really set up, and then we're just on a gameplay code, which we'll just kind of do as we do. Now, we're not game designers here on Handmade Heroes, so that part of the process is going to be pretty ad hoc, and it's not really going to be about learning because, well, I can't teach you that. Someone else is going to have to teach you that. We're getting pretty close, I guess is what I'm saying. We've done a lot of work, and we've pretty much built an entire game from scratch, and we're almost up to the part where we would really step back and say, game designers, it's your turn now. But we still have some quality stuff to do before then, and we will actually do the game design ourselves, for better or for worse, after that process. And it'll be fun anyway to just have a game that we made, even if we're not particularly talented at that part, right? I mean, you make the whole engine and get everything working and support all this cool stuff, you might as well design a little game in it, right? So yeah, so we're getting pretty close, and you know, doing the world building I think will be fun, because that is about programming and you know, tying that stuff together. So I think we'll enjoy doing that, because it's kind of rewarding to see the world come together as well, and all that stuff. Anyway, that's it for today. I'll be back here next week to start on that side of the process. Hope to see you back here for that. Till then, have fun programming. I'll see you everyone on the internet. Take it easy, everybody.